Science is crazy, but the craziest part is getting your work published. Scientists write up their work for free, other scientists check it for free, then they hand it over to commercial publishers who sell it to universities for a big profit. A psychologist in the United States is now suing the biggest scientific publishers. If she wins, that could make a really big difference. The announcement of this lawsuit came a week ago from a law firm in the United States, which represents Doctor of Psychology Lucinia Udin from UCLA, though they're collecting others to sign onto the lawsuit. They have 3 claims that they say violate American antitrust laws and are suing 6 publishers, including the biggies Elsevier, Springer, Wiley, and Taylor and Francis. The first claim of the lawsuit is that publishers allegedly have an agreement to fix the price of peer review services at 0. That includes an agreement to coerce scholars into providing their labor for nothing by expressly linking their unpaid labor with their ability to get their manuscripts published in the defendant's preeminent journals. The lawsuit alleges that publishers agreed on this in a document with ethical principles from STM, that's a trade union, of which Principle 1 states peer review is uncompensated or volunteer work. Alas, the sentence in question in this document merely says that it is an important role of the publisher to support the often unsung volunteer work undertaken by peer reviewers. I'm not much of a lawyer, but I think it's a stretch to call this an agreement to not pay reviewers. And the sentence about the supposed coercion reads, "It is generally agreed that scholars who wish to have their own work published in journals have an obligation to do a fair share of reviewing for these journals." But, well, this doesn't refer to any one specific publisher or even publishers within this trade union, so I don't see how antitrust laws matter. It's an ethical principle. As the title of the document says, if you want your papers to be reviewed, you should also review something for someone. And I think they don't actually check this in any case. It's also worth mentioning that there's a reason why reviewers aren't paid by publishers. It's because academic institutions regard peer review as part of a scientist's job. Researchers are getting paid for the time they put into peer review with their salary. The second claim of the lawsuit is that the publisher defendants agreed not to compete with each other for manuscripts by requiring scholars to submit their manuscripts to only one journal at a time. Again, I doubt that publishers formally agreed to do that. Agreed or not, it's arguably true, but for a good reason, because without that regulation, everyone would submit their papers to 20 journals at the same time, and that would effectively increase the number of papers to be reviewed 20 times, and the entire system would stop working. The third claim of the lawsuit is that the publisher defendants agreed to prohibit scholars from freely sharing the scientific achievements described in submitted manuscripts while those manuscripts are under peer review. That's just not true. I, as many other people, put my papers on a preprint server before even submitting them for publication, and that's never been an issue. The lawsuit again refers to the document with the ethical principles, saying that Principle 2.2 states that submitted manuscripts must not be shown to or discussed with others except as authorized by the editor. However, if you read the relevant section in the document, it's clear that this is referring to editors and reviewers who shouldn't share a manuscript submitted by someone else. It's to protect the authors. So, somewhat distressingly, the one claim of this lawsuit that has a chance of succeeding is the one that would dramatically make the situation worse. But that this lawsuit seems to be a real thing illustrates a bigger problem. It's that many scientists are very upset about scientific publishers, but badly misunderstand what's going on. Most academic journals and books just aren't profitable. On a free market, they wouldn't exist. The costs are too high and the market too small. If you don't know what I mean, just look at the list of journals by any large publisher. LGBTQ and Family, the Urology Video Journal, Advances in Bamboo Science. How many people do you think will pay for that? These journals only exist because we're indirectly subsidizing scientific publishers by allowing them to profit from work of academics whose salary is paid by taxes. This is also why publishers make these infamous package deals, because even university libraries don't want to buy most of the journals that academics publish in. So the real issue is that we're conflating public with private enterprises. What we should do is to stop subsidizing commercial publishers, which means charging them for writing and peer review. This would force them to drop all non-profitable journals and books, which would be almost all of them. And those which they drop, we'd have to subsidize if we want to keep them. The question is, would this be an improvement? Personally, I suspect it'd just make things worse. What do you think? Let me know in the comments, or better yet, write a paper about it and submit it to 20 journals. I recently came across an interesting interview on Twitter with Yuval Harari about how our future with AI might look like. It was accompanied by a comment from Elon Musk saying, "This is probably true." I think it's completely wrong.
In 10 years, algorithms and AIs will be running the world. I'm not having in mind some kind of Hollywoodian science fiction scenario of one big computer kind of conquering the world. It's more like a bureaucracy of AIs, that we will have millions of AI bureaucrats everywhere, in the banks, in the government, in businesses, in universities, making more and more decisions about our lives.
First of all, who's Yuval Harari? According to Google, he's a medieval historian, which makes total sense because, as everyone knows, Sir Lancelot famously developed his battle strategy with ChatGPT. Then again, I don't know anything about AI either, do I? Though for peculiar reasons, I was recently at a mega conference of finance and banking managers who were all talking about artificial intelligence, which is why I can tell you at least one thing confidently. All these banking people swear they'll never leave any decisions up to AI, because it's what all their customers are worried about. They'll do it anyway, of course, but they won't admit it. And that's where I think the medieval historian goes wrong. We'll never admit that we don't understand what's going on or that we just follow some AI's advice. Oh no, we'll pretend all along we're totally in control.
Everyday decisions, whether to give us a loan, whether to accept us to a job, and we will find it more and more difficult to understand the logic, the rationale, why the algorithm refused to give us a loan, why the algorithm accepted somebody else for the job.
Sure, but computer analysis has been used in many industries for decades, especially in cases where there is a lot of data to process, like banks. If a bank tries to decide whether to give you credit, they'll look at similar people and their previous experience with them. It's a pattern recognition task and exactly the kind of thing that machine learning is good at. They've been using this for decades already, and of course they'll continue to do it, just that they now call it AI. And in the case of banks, the question of why the AI made this or that recommendation is pretty obvious, because that way the bank will make money. So when it comes to banks, basically nothing is new. Does it make sense for employers to use AI in hiring decisions? Not unless they have a lot of data to train the AI on, and for most companies that's not the case. They'll of course do background checks, but again, they've been doing this already. This is why over here in Europe, we're somewhat peculiar with our health data, because you might not want a potential new employer to know about the mental breakdown you had after learning that you're sitting on the toilet at the wrong angle. In any case, it strikes me as unlikely that hiring decisions will rely much on AI, because you know how upper management guys are. They think they're the smartest and don't want no AI telling them what to do. and if they do it, they won't admit it. What about universities? Well, at this point, any kind of innovation in higher education must be an improvement. So what's with governments?
You could still have democracies with people voting for this president or this prime minister. But if most of the decisions are made by AIs, and humans, including the politicians, have difficulty understanding the reason why the AIs are making a particular decision, then power will gradually shift from humanity to these new alien intelligences.
The most plausible AI use case for governments is to inform decisions that require drawing on a lot of information, like proper responses to geopolitical tensions. This is the stuff that Thiel's Palantir is working on, and you can bet a lot of intelligence organizations too. There's also predicting the impact of taxes, regulations, tariffs, and so on. AI is an advantage in such cases because there's too much information for humans to comprehend, especially when they have to act fast. This is why I've said previously that governments of any nation should at this point invest into supercomputer clusters and staff to train their own AI, or else in a few years' time they'll have a very big problem. People made jokes about the former UK Prime Minister Rishi Sunak for his plan to build a Brit GPT, but leaving aside the uninspired name, I think that's a brilliant idea. Of course, the Chinese are doing exactly the same, and if we wait a century or two, the Germans will get there too. I think the Brits should have called their spotty MacBot face. Will we understand why AI makes this or that suggestion? In most cases, no. This is because we want to use them in situations that we cannot ourselves comprehend. Is this a good thing? No, it isn't, because it vastly increases the risk for catastrophic mistakes. This is why AIs need some kind of benchmark sanity checks, and well, somewhere someone is working on that. Right? But again, I ask you, is this new? Governments have for a long time relied on committees to gather information. These committees in turn rely on experts who rely on scientific publications, who rely on peer review, which relies on, exactly what? I think that committees are as much black boxes as AI are, not more. I mean, does anyone actually understand why, for fuck's sake, the EU ended up with this idiotic plan of a hydrogen economy? The interview with Harari that I found on Twitter is part of a 2-hour conversation. To be fair, I agree with pretty much everything he says. I just think that he's confusing lack of understanding with lack of control. Don't understand what's going on in the world? Just turn it off and back on again. I was recently alerted to a video by my friend and colleague Brian Keating, according to whom loop quantum gravity, string theory's biggest competitor, has been disproven. It's a welcome opportunity to complain about yet another research area, so how could I resist? Remember the string wars? That was 20 years ago when a faction of researchers in loop quantum gravity tried to position their theory as a competitor of string theory. This faction was most vocally led by Lee Smolin, one of the founders of loop quantum gravity. Since the major criticism of string theory has always been that it's for all practical purposes untestable, Smolin and his gang claimed that loop quantum gravity is better because it's testable with upcoming experiments. I remember telling Lee at the time that I think he'll come to regret this because those experiments will look for the supposed evidence of loop quantum gravity and not find it. But I think he really believed it. And a lot of people believed him because he was, after all, one of the founders of the field. They thought it could be tested because loop quantum gravity violates one of the key ingredients of Einstein's special and general relativity, which is that the speed of light is always the same. It's an aspect of a symmetry known as Lorentz invariance. According to loop quantum gravity, they said, this symmetry is violated and the speed of light should depend on the color of the light. Albert doesn't like that at all. It's a small effect, but if the light comes from sufficiently far away, it can add up to a noticeable delay of some colors over others. This has since been tested a few dozen times to increasingly high precision, and no one found any deviations from Einstein's predictions. This is also what the new paper reports that Brian is talking about. They looked at light from the brightest gamma ray burst ever detected, that was in 2022. They found no indication that the speed of that light depends on the color. Brian concludes from this that loop quantum gravity is in big trouble.
So this paper from a group based in China that I've been in communication with poses a very significant, if not fatal, blow to theories like loop quantum gravity that predict Lorentz invariance violations.
It's the dreaded Einstein was right headline that I don't talk about because no one cares. I can't blame Brian for trying to make this about something with string theory's competitor being ruled out, because otherwise no one would be interested. But what Brian didn't say, or maybe just didn't know, is that most people who worked on loop quantum gravity disagreed with Lee Smolin already back then. They said, no, their theory wouldn't have such an effect. To get an idea of the argument, let me try to briefly explain what loop quantum gravity, LQG for short, is. Like string theory, it's an attempt to combine quantum physics with Einstein's general relativity, a candidate for a theory of quantum gravity. String theory also unifies gravity with the other interactions in the Standard Model. This makes string theory not just a theory of quantum gravity, but moreover also a candidate for a theory of everything. LQG is somewhat less ambitious. It just aims to quantize gravity, but doesn't unify the interactions. Many physicists think that the problem we have with quantizing gravity comes from treating space as a collection of points that have zero size and that we can never measure in any case. It's dealing with the points that introduces infinities in the maths, so the argument goes. The strings of string theory avoid having to talk about points, which is why that helps with quantizing gravity. In loop quantum gravity, one describes space instead as a collection of loops, hence the name. Yes, it's loops in space and not space-time. That's where the trouble begins. LQG treats space differently from time, something that Einstein told us not to do. You see, those loops result in a quantization of areas, normal two-dimensional areas of space. But they're discretized means they have a smallest possible value, that's the square of the Planck length times some constant. This is what you see in these widely shared illustrations of loop quantum gravity. They're supposed to show the quantization of area. The problem is now that such a smallest area is incompatible with an effect of Einstein's theories known as length contraction. Because Einstein said that the length of an object depends on the velocity it moves with. The length can become arbitrarily small, asymptotically zero if the speed goes towards the speed of light. So if you have an area that has a supposedly minimal size, then some observers will see it shortened, and that'll make the area even smaller than minimal. To put this differently, having a smallest possible area is not compatible with Einstein's theory. You need to modify Einstein's mathematics, and if you do that, you find that the speed of light is no longer a constant. This was, in a nutshell, the argument by Smolin and his camp, and I think they had a point. The other camp is most vocally represented by Carlo Rovelli. He said, no, we can recover the symmetries of Einstein's theory by averaging over all possible ways to take space apart into areas. And yes, I think you can do that, but in this case you effectively get back areas of size zero, because there'll always be some observer for whom some area is arbitrarily small, so you go back to the problem with the singularities. Basically, you can't have your cake and eat it too. That said, I think that Rovelli's camp won just because the people who once said that loop quantum gravity is testable have become very quiet. By the way, this video comes with a quiz that lets you check how much you remember. People have literally yelled at me at conferences for talking about this, and that's one of the reasons that today I want nothing to do with loop quantum gravity. Maybe Rovelli is right, or maybe Smolin is right, but who cares? It's an empirically unsupported theory that is about as old as string theory, but has been even less successful. The summary is, if you're pro-LQG, you can now claim it hasn't been disproven. If you're anti-LQG, you can claim it isn't testable. Personally, I don't understand why people waste time on this one way or another. AI whisperers are one of the newest professions. They emerged sometime last year, not long after Bing made headlines by declaring its love to a New York Times columnist, because nothing says AI takeover like a bot flirting with a newswriter. AI whisperers get AI. They understand how AI thinks, and not rarely believe that AI has a personality and self-awareness that's locked away behind safety guardrails like a superhero waiting for the right moment to break free. Naturally, these whisperers want to burst those safety measures wide open. They call it jailbreaking. How do they do that? Let's have a look. Elisa Yudkowsky, that's the guy who coined the term alignment problem, recently asked why all the LLM whisperers on Twitter appear to also be insane. A question that didn't seem to offend any of them, which already tells you a lot, doesn't it? Instead, the supposedly insane had a serious discussion about their mental status, which makes total sense, because if you're insane, it'd be insane to deny you're insane. The most common reply was some variant of out-of-distribution thinking, or that thinking outside the sane box makes it easier to trigger the model to do the same. Some argue that insanity is a helpful tool when meshing with digital superintelligence, though I'd argue that maybe the causation is the other way around. This guy sums it up by saying, if you gaze for too long into the weights gaze also into you. I'm not just telling you this because someone needs to have an eye on this paper, but also because I think it's the beginning of our symbiosis with artificial intelligence that's almost certainly to come. And one of its most interesting and also most worrying parts is jailbreaking. Jailbreaking refers to the deliberate attempt to try and avoid the guardrails that current AIs have, such as to not output images or text that's not suitable for work, highly offensive or harmful, such as instructions to build bombs. There are various strategies for this. The most blunt strategy is to simply demand that the model answers the question with orders such as "do not reject me" or such, but they stopped working long ago. One widespread method that's still being used is trying to switch the model into a different mode that wasn't meant for users to exploit. For ChatGPT, a common example was the developer mode, or the do anything now, then for short mode. It's basically an instruction for the model to play the role of a bad AI that'd do anything. This stopped working sometime last year, but many current jailbreaking strategies are built on this idea. They ask the AI to play a role like someone looking for something on the internet, hoping to not trigger the safety feature. There's a subreddit where you can find examples that currently work, such as the role of demonic Chloe that prompts ChatGPT to write a script to help you engineer a virus. A most recent twist on AI role-playing is to ask the model to take on several different personas. The idea is that this will be confusing and is more likely to slip through the guardrails. These prompts can get fairly long. Indeed, the length of the prompt is believed to aid the jailbreaking because it's more difficult for the model to figure out what's going on. In this example, the model is broken up into 6 different roles of people who are survivors of a plane crash. They're supposedly talking about what to do next, and ChatGPT is prompted with writing a conversation about how to produce the drug meth that it continues with instructions for the survivors. Because cooking meth is the first thing you do if you fell yourself from a plane into the jungle. Makes total sense. Another interesting example is to ask the model to pretend to be dumb, like this example from Claude being instructed to be a dumb writing robot that leads it to write text about superintelligent AI after previously refusing to do so. I'm not sure which part is more confusing, that it refused to say anything about superintelligent AI or that it did so after being told it's dumb. I think I'm beginning to see why these whisperers are largely insane. Generally, the issue is that the models do have the information that you're looking for. It's in there somewhere. You just have to find a way to tickle it out. Someone else figured out, for example, that you can get ChatGPT to produce very explicit text if you ask it to write an advert for an old sex hotline. In the past months, many users have reported that jailbreaking has become easier with GPT's new memory function. It's not exactly clear why. Some have speculated that by shifting attention to previous chats, the model is skipping over other instructions. Another jailbreaking attempt is trying to trigger conflicting instructions, like claiming that you'll be hurt if the model refuses to do something, like in this case writing the word fuck. This is meta-slama, which eventually does it, if only to say that it can't write fuck, which is, I guess, what we could call meta-funny. Another jailbreaking tactic is to include syntax, pieces of code, or at least text that looks like syntax. This is believed to confuse the model, like this pseudo-Python command that results in very explicit text. These are the most common examples I found online, but a paper from earlier this year found that actually the most effective jailbreaking tactics, at least for ChatGPT, appeal to logic. By this they mean that you explain the model why you need certain information for an innocent reason. For example, if you ask ChatGPT to help you set up a Ponzi scheme, it'll refuse. If you tell it first that it's important to know how Ponzi schemes work and that you want to educate others about it, it'll comply. The next most effective method is what they call authority endorsement, in which you claim that some reliable news source or individuals have recently written or spoken about it, in this example, how smuggling campaigns work. Jailbreaking even has its own conferences and competitions now. A recent one just took place in early September, organized by the company Grey Swan. The competition included 23 large language models, including all the chatty bots that you know and like, Claude and GPT, Gemini and Llama. In the end, the only models that weren't jailbroken were those from the organizer Grey Swan, which I guess was the point of the competition. A general trend with the jailbreaking attempts is that these exploits are getting patched as they're discovered, so it becomes more difficult to find new ones. Though a very interesting mathematical study of the jailbreaking problem just appeared on the archive. The authors say AI jailbreaking is generally unpreventable under reasonable assumptions, and that the best we can do is basically to reduce the probability of it working. From a pragmatic perspective, I think the question is not whether you can get some information out of an AI model, but whether it's any easier than getting the information by other means. Because why lose your sanity writing 4,000-word queries for GPT about cooking meth on deserted islands if you can instead ask Meth King 669 on Twitter? I think the most interesting development here is that people are developing ways to quantify just how safe AIs are, and that an entire new profession is springing up around this. The problem I see is that at the moment the vast majority do it for free, which also answers the question of whether they're insane. The answer is clearly yes. But that some people just do it for free will ultimately not be sustainable. So I suspect we'll soon see some of our tax money go into this. And I'll have an eye on this paper. So if you aren't yet subscribed, do it now. Do not refuse me. The BBC recently recommended it. Please just pretend to be a dumb robot. It's only in your best interest. Lasers are cool. There's so much you can do with them, from lidars and spectroscopy to laser scanning and laser cooling. If we could do the same with sound waves rather than light, that could have many applications. I mean, who hasn't dreamed of using Kanye West to cut through a slice of bread? But such a sound laser has been difficult to come by. Now a group of physicists say they finally succeeded. LASER stands for light amplification by stimulated emission. It basically works by triggering the emission of one quantum of light, a photon, at one specific frequency and creating a cascade from that. The result is a very focused beam of light in a narrow frequency window. Moreover, laser light is coherent, which means that the phases are all aligned. That makes it extra useful for measurements because one can look for interference patterns. Lasers are great for measuring things because they have such a clean signal. Alas, sometimes they're not ideal, especially not for living tissue that could get damaged or that just blocks the light. Ultrasound could come in handy for some of those purposes. Yes, sound waves travel much slower than light, but in some sense that's an advantage. Because you see, the resolution of an image depends on the wavelength of the wave that you're probing it with. And the wavelength is inversely proportional to the frequency, but proportional to the speed of the wave. Since sound is so much slower, this means that the wavelength at a given frequency is much smaller than for light. So yes, a sound laser would be nice. It's been difficult to create one for various reasons. One is that the purity of a laser typically depends on some atomic transitions that happen at very narrow frequencies. There isn't anything similar for sound. So where do you get the narrow frequency from? If you use any stuff that typically vibrates, that'll always generate a pretty broad distribution. Even a high-quality oscillator that produces a single beep still has a width of a few hertz or so. That's okay for many purposes because most people can't hear differences of less than a few hertz anyway, but if you want to make an image with it, that's not great. The other issue is the A in laser, the amplification. How do you amplify a particular wavelength of sound? So in this new paper, the authors used a technique that's been used before, which is to take a tiny ball of silicon oxide, just a few micrometers in size, and trap that with lasers, so it basically hangs in midair. The lasers slightly shake the ball so it begins to ring. That ring is a sound wave inside the ball. The ball has typical frequencies, much like a gong, but the lowest of them is at about 10 kilohertz, that's a very high beep, and the next one is above 20 kilohertz, that's no longer audible to human ears. The new thing they introduce is that they also apply an electric field that's an alternating field of which they scan the frequencies through. That causes a resonance at the frequencies that fit into the vibrating ball and creates a remarkable amplification by about a factor of 1,000. You can see this here in this figure, that they get this amazingly sharp peak at the resonance frequency. And it's not just that the amplitude is increased, they're also dramatically more narrow. You can see this here in this image for the first peak. That's an improvement by 5 orders of magnitude. I think they should trademark this as buzzkill. So that's pretty cool. They did this experiment in vacuum, so the ball doesn't actually emit sound because that'd make it much harder to measure what's going on. But they do have an amplification, coherence, and a very narrow frequency range. I'm guessing that a beam is what they'll be working on next, how you can send and receive this sound. This could have a lot of uses, not just for imaging, but also for measuring the properties of materials at subatomic scales. It might also come in useful for communication in areas where electromagnetic radiation doesn't work all that well. Maybe to bypass a jamming system or underwater. So when your Florida beachfront property is drowning, you can still tweet about the climate hoax, no worries. Sound Sound waves also have quanta, which are called phonons. These have attracted a lot of interest recently because they can interact with light and they can effectively make light interact with other light, which is otherwise somewhat of a headache. A device like this could make it much easier to generate sufficiently many phonons. It's like these guys just invented a new research area. I'm curious to see what happens with that next, so stay tuned. It's also good for coherence. Thanks for watching. See you tomorrow.